Hi, everyone. We're going to go ahead and get started. Good evening and welcome to tonight's Red Barn event. I'm very excited. Tonight it's partnered with A Book for All Seasons. My name is Randy and I am the Development Associate and Outreach Manager here at the Wenatchee River Institute. I'm also the Events Coordinator at A Book for All Seasons, so I'm kind of wearing both hats this evening. And we're a nonprofit here, and our mission is to connect people, communities, and the natural world. And with me here tonight is Rebecca Ryan, our Education Director. She's handing out surveys about our Red Barn events that help with our strategic planning. So if you haven't filled one of those out, we ask you please, it's not required. Then we also have Jeremy, he's a volunteer helping us with the tech side because we have many attendees watching from home as well. And all of our Red Barn events are recorded and later put onto our YouTube channel as well. So so Wenatchee River Institute works towards our mission through our youth and community education programs. Our youth programs deliver hands-on curricula up and down the Wenatchee Valley. We're transitioning to our summer camp programs with our first camps beginning next week with the Wenatchee School District. So we had a jam-packed spring. We're jumping right into summer. It's going to be a fun time. And our community programs reach people through our many Red Barn events like this one, and also our seasonal nature walks, our workshops, and also our community garden. And we have a few Red Barn events through the summer, with our next one happening on Wednesday, July 19th, with another author named Bobby Scopa. And she wrote her book, Both Sides of the Fire Line, a memoir of a transgender firefighter. So that one's going to be really fun. And another aspect of WRI is our effort to connect Indigenous peoples to their ancestral lands here. So at this time, I'd like to read our land acknowledgement. This land acknowledgement was created alongside the Shimpisquawshu people. We are spreading the message they wish to spread to the public. The land the Wenatchee River Institute sits on is on the ancestral homelands of the Shimpisquawshu, Piscosa, or Wenatchee people. The Shimpisquawshu, meaning people in between, had villages positioned along the Wenatchee River and surrounding areas. Their ancestral homelands extend from the Cascade Ridge throughout what is now known as the Wenatchee and Okanagan valleys. The culture and economy of the Shimpisquawshu people centers on taking care of the land. They fish, hunt, gather roots and berries, basket-making materials, and medicines. The Shimpisquawshu are named within the Yakima Treaty of 1855. Language to establish the Wenatchee Reservation was never followed through, even with the needed surveying completed. Many Shimpisquawshu now live on the Culva Reservation, 150 miles northeast of Leavenworth. They were forced off their land here, and the U.S. government moved them to this reservation. The Shimpisquawshu are still alive today. They continue to practice their culture, harvest their traditional foods and medicines, and hold their ceremonies passed down from their ancestors. Most people won't see or notice them, but they continue to be on the land that they are connected to. Their traditional language is Inhampchin, an interior Salish dialect, and we'd like to welcome you all by saying hello in their language, Tilhusht. We offer this land acknowledgement as the first step to amplifying Indigenous voices and recognizing the harm done to them as a people. We stand as an ally to recognize their connection to the land and their rights to practice their culture on these sacred lands. We encourage all to learn about the Indigenous peoples of the place you now call home. The Wenatchee River Institute is committed to sharing this land acknowledgement, following up with other actions to educate and be respectful. And also another moment, I would like to thank our sponsors. There we go. So our Red Barn event sponsors help make these events possible. These events are free and by donation only. So I'd just like to give a quick shout out to Gustav's Grill and Beer Garden, Ludwig's German Restaurant, Obertel Inn, Posey Handpicked Goods, South Restaurants, Hotel Pension Anna, Moonchen House, Sleeping Lady Mountain Resort, North Central Washington Audubon Society, Icicle Brewing Company, the Cove Resort of Fish Lake, Kolchak Consignment, Riverfront Rock Gym, Mountain Home Lodge, and Mitchell Reed and Schmitten Insurance. And as mentioned earlier, this presentation is being streamed over Zoom for viewing at those at home. So during the presentation, please hold your questions till the end so that we can adjust the sound so that everyone can hear you from home as well. And one quick mention as well, our salmon sculpture ceremony, salmon sculpture ceremony is happening on Tuesday, June 27th. And you guys are all welcome to come to that event. All right, and now I'd like to introduce our speaker. Kristin Ohlson is a writer from Portland, Oregon. Her new book, Sweet in Tooth and Claw, Stories of Generosity and Cooperation in the Natural World, probes the mutually beneficial relationships among living things that undergird the natural world. Ohlson's articles have been published in the New York Times, Orion, Discover, Gourmet, Oprah, and many other print and online publications. While she has written about many things over her long career, she's now focused on the work to regenerate landscapes in cities. And with that, welcome, Kristin.
Thank you. This is such a pretty place. It's such a pretty building, and what a great view. And thank you all for coming on a night when you could really be doing something very nice outside. A couple of months ago, I was interviewed on a podcast, and the guy said, he said, were your parents campers and hikers and outdoor people? And is that why you got this interest? And I said, oh no, my parents liked to travel, and they liked board games and bridge and golf, and they liked to have friends over and drink cocktails and sing around the piano. And this is a picture of my mother in what I think is a bathing suit. I had never in my life seen her get in water other than a bath. So even though we lived near a large and beautiful lake, not that that's the large and beautiful lake, but we did. And no, they didn't, my father liked for going for walks in the woods, but he worked in the timber industry. And I think it was all his admiration of the trees there was all about board feet and dollars. So no, none of that came from my parents. I spent a lot of time doing this, reading. And I also spent, oh, that's very big. But I also spent, there was an empty lot near our house. And so I spent a lot of time looking at ant hills and looking at all the little ant highways that went between all the ant hills and sprinkling sugar and breadcrumbs there and sometimes putting sticks in their way to see how they moved things around. And if anything, I think that is where I first learned that the lives of other creatures are fascinating. So my new book, Sweet in Tooth and Claw, was inspired not so much by the memory of those ants, but by this, the soil ecosystem surrounding plants. So there were many pleasures for me in writing my other book, which is called The Soil Will Save Us. I got to meet farmers and ranchers and foodies and scientists who were trying to figure out how to raise food without ruining land, which is what most of our agriculture does. But one of the biggest pleasures for me was learning that plants are givers. You know, there's a whole huge multi-million, maybe multi-billion-dollar industry of agrochemical companies that have made a lot of money on the idea that plants are just takers, that they just suck everything nutritious out of the soil and leave it empty of nutrients so that farmers are always having to put in new nutrients. So it was kind of stunning and wonderful to me writing this book to find out that plants are givers, that givers and takers. So there's, in that soil, only the fungi are really visible, but in that soil are billions and billions of microorganisms, bacteria and fungi and protozoa and all these tiny little things there that are involved in a constant give and take with the plant through the roots. So as you probably recall from elementary school, plants feed themselves by taking carbon dioxide out of the atmosphere and turning it into like a carbon sugars. I like to call it a carbon fuel. And they take that carbon fuel, that carbony liquid, carbon syrup, and they grow their leaves and their fruits and their flowers and all of that. But they exude much of that fuel through their roots to that community of microorganisms in the soil in exchange for minerals and nutrients and water and chemical messages. So I didn't use the word mutualism in that other book, but that's what this is. It's a mutually beneficial relationship that involves 2 or more species. And almost every living thing, and I say almost when I think probably every living thing does, but you know, scientists can't say that every living thing engages in mutualisms because they haven't tested every living thing. So they, you know, probably likely that every living thing engages in some kind of mutualism, and probably many more. So it's really difficult and time consuming to study them. I do know that that scientists did find one 3-way mutualism in Yellowstone Park. And so in this case, the plant has a symbiotic mutualism, and symbiotic just means it takes place in the same area, like for bees and flowers, they're in separate areas. So that's not a symbiotic mutualism. So in this case, the plant had a symbiotic relationship with a fungus, which means it was inside the plant. And then the fungus also had a symbiotic mutualism with a virus that was also inside the plant. And those relationships give this plant a superpower, which is that it can tolerate the heat near scalding geysers and vents. But the mutualism that most people are familiar with and see probably every day is the one between plants and bees, in which bees visit plants to collect nectar, and in the process get dusted with pollen, and which they carry off to other plants, and then the pollen fertilizes those other plants so that they can make fruit. So both partners benefit. The bees get nectar and a little pollen to eat, and the plants get help with reproduction. And there are probably, again, dozens of other ways, maybe hundreds of other ways that they benefit from this mutualism, but scientists haven't yet documented that. And scientists have recently figured out that there's a very similar mutualism at work in the sea. So these tiny little crustaceans kind of do what bees do. They climb up and down seaweed, and they get covered in something that the seaweed makes that's like pollen, and they carry that to other seaweed and fertilize seaweed that way. And the seaweed not only offers these little crustaceans protection and habitat, but it also hosts microalgae on the surface of the seaweed that these little crustaceans eat. So this is like a pretty new discovery, and scientists think that whole method of fertilization, that third-party fertilization, may have started in the seas. So every ecosystem is held together by these mutually beneficial cooperative relationships among 2 or more species. We human beings and the ecosystem of us, and that's my granddaughter. In the ecosystem of us, we have many mutualistic relationships with the 35 trillion bacteria that live in us and on us. This is one that lives on us. It lives on our skin and in our saliva and in our feces. And it also lives in the soil, and it's also used to make camembert cheese, I think. I think they take it out of the soil, not out of poop. But, so that's our microbiota, the bacteria and the viruses and the fungi and all these tiny little things that live in us and on us. And, you know, it's kind of amazing because doctors really didn't even know that existed until, you know, a couple of decades ago. And now we're learning that our microbiota affects just about everything about us. Our digestion, our metabolism, and disease prevention, and tissue repair, and even our brain processes. Just one indication of the importance of our microbiota. When women have babies, we produce milk for those babies. We produce a fluid for those babies. But what's in that milk at the beginning, when the babies first start to nurse, there's a lot of carbohydrates in that milk that the babies that the babies can't digest. It's the microbiota inside the babies that's feeding that microbiota. So like one of our first jobs as nursing mothers is to support this internal partner that each of us has. It kind of reminds me of the golden compass, you know, where each, I won't go into that, but that's it. So just about every visible living thing, fungi, plants, animals, have microbiota that perform vital functions for their host or their partner. That might be a better word for it. So mutualisms are everywhere and are responsible for everything working well, from the fertility of the soil to the health of our coral reefs and forests and rivers, everything. And in fact, mutualisms created life on Earth as we know it. Billions of years ago, Earth was populated only by single-celled organisms. And then about 1.5 billion years ago, two different microorganisms came together to form a more internally complex cell. And that more complex cell was able to form, join with other cells and form multicellular organisms. And these are called eukaryotic cells. So they're created by cooperation between two ancient microorganisms, and they pretty much make up everything that we see, every living thing that we see, because we can't see microorganisms. So people, animals, other animals, all of that. But if we and all these other multicellular organisms are built with cooperation from the ground up, and if all systems are held together by mutualisms, so why is it that most people think nature is mostly formed and animated by competition and conflict? So people who think that nature is red and tooth and claw, which is a line from Tennyson from 175 years ago, in which I tweaked for the title of my book. So why are we so hooked on competition and conflict? Well, it's more engaging to watch. I mean, it's exciting to watch. My partner and I do a lot of birding, and I look at birds, and they're so beautiful, and we love watching them. We love watching them float and feed and, you know, nuzzle up to each other and all that. But it really makes a big impression when an eagle arrives to snatch a duckling out of the pond. You know, it's like, whoa, that is more exciting. We humans are drawn kind of by necessity to dramatic ruptures, and especially to what doesn't work in our own societies and to what threatens us. It's that alertness to danger that keeps us safe. And competition and conflict are more fun for scientists to study. And more gripping for storytellers. I mean, just think about all the documentarians, the people who make nature documentaries, and how long they have to sit and wait for that one shot of the lion ripping off the head of a gazelle. You know, they wait a long time for those shots. So there are plenty of reasons that competition and conflict demand our attention. But one has its roots in the Industrial Revolution and the ideas that were swirling around then. And those ideas wound up shaping the theories of one of the world's most influential scientists, Charles Darwin. So Darwin was a wonderful and fastidious observer of nature, and he and many others not only observed that there was a dazzling, amazing amount of diversity of life in the world, but that also there were fossils of things that no longer existed. So he set about trying to solve that mystery. Like, why is it that there are there's such incredible diversity, and why is it that some didn't make it? And he was working at, you know, he did all these observations. Then he spent like 20 years sort of, you know, fiddling around with the observations, trying to come up with a theory. And at around that time, there was a lot of contemporary thinking about struggle and survival. So one of the most prominent voices in this arena of struggle and survival was Thomas Malthus, who was a wealthy pastor who argued that human reproduction would always outstrip food and resources, but that struggle over those resources and even death for the lack of those resources were actually good for society. And Darwin, when he was casting about for a theory to wrap together all his observations, read Malthus, and in his ideas of progress through struggle, found a way of uniting his observations of nature. So thus his theory of evolution. There's natural variation that arises within any population. And here, I just found this in my garden. It's a big bunch of a perennial plant called a salvia, and it changes. You know, they're not all the same. They all came from the same plants, but sometimes the leaves are smooth, sometimes the leaves are wrinkled, sometimes the leaves curl, and sometimes they're white. So that there's natural variation that arises within any population, and the individuals with the variation that gives them the greatest advantages in harvesting resources and surviving adversity and producing offspring move on, and the ones without those helpful variations fail the competition and die out. Well, the problem with that, there are two problems with that. One was the application of Darwinism to something called social Darwinism. So that was a theory in the late 19th and early 20th centuries, which basically held that individuals and cultures thrived because of their innate superiority. Whereas today, we don't really think that way. We understand that much of what makes individuals and cultures and societies thrive or fail is the structure of society and its overall culture. But then the other problem is that Darwin's focus on progress through struggle and competition is that it encouraged scientists to miss the role that cooperation plays both in evolution and in the way the world works around us all along. So the study of mutualism has been a very slow slog, and one of its earliest and most famous proponents was a Russian scientist named Peter Kropotkin, who was a young man when Darwin's Origin of Species was published, and he was a huge fan. So he was born a prince who fell in love with politics and science, and he left the court of the Tsar and took off on his own 5-year journey to make observations of nature and follow up on he thought he was going to follow up on Darwin's work, but instead of observing competition for resources as he expected to see, what he saw was mutual aid, was animals helping each other find shelter and food, as well as enjoying each other's company. So his book, Mutual Aid, was written as a rebuttal to some of Darwin's other supporters who he felt had taken the idea of competition to extremes. So when I went looking for this book and other books by Kropotkin, I went to this bookstore in my neighborhood, and a used bookstore, and it was one of those like classic used bookstores. It had been there forever. The guy who owned it had been there forever, you know, that there were piles of books, piles of dusty books, and shelves just jammed with books, and he knew every single book that was in there. And I walked in and I said, and he always sat on this stool so that he was, when you walked in, he was sort of looking down at you. And I said, well, do you have anything by Peter Kropotkin? And he kind of looked at me and he said, I haven't seen anything by him in years. And I think the reason he looked at me like that is that Kropotkin is now mostly known and still read because of his anarchist views, not because of his scientific views. So he was a hugely influential and popular scientist in his day. He would go on speaking tours of the US and Canada and Europe. He was always sort of trying to keep, he had to flee Russia, and he was always trying to keep ahead of the Tsar's secret police. But he would go on these speaking tours, and just thousands of people would come, and he would talk about geology, and he would talk about evolution, he would talk about anarchism, and he was hugely influential. And he was the kind of anarchist, kind of not like the Antifa that we think of today. He was an anarchist who believed that general strikes by workers were going to bring a halt to the centralized state. And he remained throughout his life devoted to that cause. And he actually turned down a very prestigious chair in geology at Cambridge University because he would not renounce anarchism. So his influence was really strong until President McKinley was assassinated by an anarchist in 1901. And then the tide sort of turned against him and against his ideas. So that champion for mutualism, for cooperation in nature sort of faded away and science went on. So the study of mutualism then was slow through most of the 20th century. And then an evolutionary biologist named Lynn Margulis began arguing back in the 1960s that life on Earth was transformed by those two ancient single-celled organisms coming together and forming this more complex cell that led to multicellular life, which I mentioned before. And she was super controversial, and she wrote this big paper and it was rejected 15 times before anybody would publish it. Now, of course, her theories are widely accepted, and it really boosted the idea that living things engage in mutually helpful behaviors. And not that the study of mutualism really took a huge leap even then, because so one of the scientists that I interviewed for the book studies this, which is the Hawaiian bobtail shrimp. And it has a mutualism with a bioluminescent bacterium, a bacteria that can make light. And with this mutualism, this little squid, which only hunts at night, can make its body light up so it blends in with moonlight in the water, so that it avoids prey and can sneak up on. Avoids predators and can sneak up on its own prey. So anyway, I told her she told me when I was interviewing her, she said, yeah, when I first started studying this stuff, people just thought it was the weirdest, most backwater, weird stuff to be writing about. Now it's more mainstream, even though I think science still devotes more attention to competition. But anyway, why did I want to write about this? I mean, other than, why does it matter if whether or not we know that nature is equally cooperative, if not more cooperative than competitive? I mean, to me, it's just incredibly fascinating to look out at any landscape and know that out there, all these living things are kind of saying to each other in chemical messages, I've got this, do you want this? I'll shelter you if you do this. So I just think that's fascinating. But aside from the fascination, I think it matters because of what it says about us, who are, of course, part of nature, and about what our role can be on this earth. So if we assume that nature is red in tooth and claw and that only the fittest survive, that leads to a zero-sum game of the world. It suggests that whatever we take has to come at the expense of other living things and from our overall shared environment. And as we humans keep growing in number, the rest of the world, this line of thinking goes, the rest of the world is just going to have to suffer. And there are a lot of people who think that human impact and engagement in the natural world can only be terrible for other living things. And they conclude that we're all just sort of doomed together. But I think, what if we've been missing the generosity and cooperation in the natural world all along? And what if we're missing the generosity and cooperation in ourselves? If we start paying attention to that, could we begin to see ourselves as partners and helpers instead of exploiters and wreckers? So I'm convinced that if we look for wisdom and guidance, and we have to seek wisdom and guidance not only from science but from the thousands and thousands of years of accumulated traditional knowledge from indigenous people, that we can learn how to be healers in the landscapes where we live and work. So I'm going to give a couple of my favorite examples of how people are doing this. on ranches and on farms and in cities. So the first one is about Eastern Nevada. And I just love this story so much that it actually always makes me a tiny bit teary thinking about it. So back in the 1970s, scientists and government agency staff in Eastern Nevada became concerned about the degradation of the creeks and the effect that that was having on local trout. And the main thing that was degrading the creeks was cattle ranching that had been going on in the area for over a century. So Eastern Nevada is super dry, as you probably know. And it's got these little threads of water going through it, and everybody wants a part of those little threads. The ranchers want to be ranching on part of those threads, and the animals want to go there. And the cattle especially like hanging out on those little threads of water. And they'll if left to their own devices, they'll hang out there for the whole 8 months that ranchers turn them out onto the land. And they do a lot of damage. They eat all the vegetation alongside the creek. And not only that, their hooves sink in the mud and break up the grass, the roots and the tubers that are there. And so vegetation just dies around the roots. And there's nothing to hold the banks in place. And they're, so the creeks were in very bad shape. They were shallow. They were too warm without that vegetative cover. They had eroded their banks so much that they had created gullies. So they were down in these gullies, and they dried up in the middle of every summer. And a lot of the ranchers figured that this was a very dry environment. And these creeks had always been like this because in recent memory and living memory, that's how they had always been. But there was historical evidence that these creeks weren't always like that. So the Donner Party, remember the Donner Party, the doomed Donner Party? The Donner Party had come through that area, and their letters and diaries talk about these creeks that were full of water and full of fish and, lots of vegetation. And there was also a memoir that some of these people were reading in this area, written by a rancher who remembered, who recalled that the creeks back in the 1860s were also, full of life and full of water and all that. So these scientists and government agency folks approached a group of ranchers and asked if they were willing to try changing the way they handled their cattle. And a few said yes. Even though they weren't at all convinced that things were going to change, even if they changed the way they did, because they figured the creeks were always like this. But these ranchers were struggling to make a living. They were struggling with the dry conditions. They were struggling with fire. They were struggling with their federal landlords, who some of these agency officials represented, and struggling with the lack of forage. So they decided to try to make a go of this thing, try again, a new way of making a go at this thing that their ancestors had started. And some of them were really weary of being regarded as the bad guys environmentally. They loved their work, they loved their ranches, they hated being seen as the wreckers. So the plan was for the ranchers to let their cattle graze along the creeks starting in late winter, but to keep them away from the creeks in the spring and the early summer when all the plants were getting going and starting to grow. And even though there was bare soil there, things did start to grow because there are always seeds that remain in the soil that sprout when they have the right moment, and there are seeds that birds drop in, and things started to grow along the banks. They started to fill in. They started to fill in with willows and rushes and grasses, and to keep the cattle away for the periods of the year that they wanted to keep them away, they used this portable fencing. And the cattle would get tangled up in the fencing, and the ranchers, struggled with that, but they stayed with the program. So things were looking good. Everybody was really pleased about this. And then these guys showed up. And the ranchers were really dismayed because they sort of fight with beavers all the time. The beavers get into their irrigation systems and screw them up. And the ranchers' habit was just to shoot them every time they saw them. And there weren't even a lot of beaver in this area anyway, because they had been trapped out in the 19th century. There was even the Hudson Bay Company had instructed its trappers at a certain point to kill every bee, even the ones they could, even if they couldn't carry the pelt away with them, to kill every beaver and create a fur desert because they didn't want their rival fur companies to get those furs. So there weren't that many beaver, but here they come, they show up and they start doing what they do, you know, cutting down willows and grasses and whatever and building dams. And the ranchers who were really proud of that new vegetation that was starting to grow there, they were sort of watching it all glumly. And the scientists said, okay, well, let's just see what happens. And what happened over the next few years was just amazing. Water that once moved fast through the landscape was captured in ponds and started to leach out into the desert. And the zone of riparian vegetation, the plants growing near the creeks, expanded and grew out more and more, adding not only more pasture and forage for the cattle, but more habitat for wildlife. In one section near one of the creeks, and I think this might be that creek, the amount of riparian vegetation increased by more than 500 acres in 11 years. And in one section of the Susie Creek, so there are a bunch of creeks with different girl names, the riparian vegetation increased by 100 acres. The amount of open water in this area, so think of all those ponds, increased in that section by 20 acres. And the actual length of the creek, I just love this, the actual length of the creek increased by 3 miles because of all those creeks had ponds and curves and twists and turns. So because of all those ponds and twists and turns, the water table in the landscape changed, it rose. And what used to be desert in this area is now wet meadows. And the land has now what one of the ranchers describes as a subterranean bowl of water that continues to nourish life even during intense drought periods. And the creeks have stopped drying up in the middle of summers. And that's because the ranchers, informed by science, changed both their cattle management practices and their beaver management practices. And they changed the way they work with each other. So their story shows that people of starkly different experiences and viewpoints and backgrounds, even people who have had conflicted relationships in the past, can work through their differences and arrive at consensus and even respect. So to help this change in land management, one of the ranchers and one of the agency staff organized a group that met, I don't know, every couple of months for a while. I think now they meet twice a year. But this group that meets and they meet around this big round, they make a round table out of a bunch of square tables. And the first time they got together to meet, they said, well, what is it that everybody wants from this land? Let's see what all the different things are that people want from this land. And it turned out they all agreed. They all wanted a healthy landscape. And to help them work together through this difficult process, it's hard for people to change the way they do things. So it was, there were going to be a lot of hurdles to jump and things to try out. And they decided that to work together well, they even wanted to bring in a trained facilitator who specializes in conflict resolution, collaboration, and consensus. And she told me, she said, and she does this a lot with, especially with land-based issues. I think she works for Fish and Wildlife. She said, every consensus-based workshop gets emotional at some point. Hell, I cry at all of them. So even when she wasn't there, they continued to do things to build trust and camaraderie within the group. They always try to sit at a round table so that nobody appears to be at the head of the table. And they have this elaborate serpentine greeting every time they get together where they all, peel up one by one away from the table and shake hands and talk to every single person. And then they reverse it and do the same thing all over again because they don't want anybody left out. They don't want people who might disagree to stop talking to each other. So similar work is going on at farms around the country, similar in that farmers are working with scientists, learning how to raise vigorous crops in ways that support all the other relationships in the ecosystem. So I wrote about this farmer in my Soil Will Save Us book. He's this amazing farmer in North Dakota who figured out a few decades ago, after really bitter trial and error and almost losing the farm several times, that he could raise as much, if not more food than his neighbors if he did not follow the conventional farming playbook and everything he'd been taught in ag school. So no pesticides, no fertilizers, no tilling, no GMOs. Gabe learned that he could become very successful by mimicking how nature grows things. So like here in this photo, okay, this is just a meadow. I think it's in Germany. So we see plants growing in abundance here in this natural environment. Nobody ever looks at this meadow and says, well, who fertilized that? Why are they growing so well? Because that seems silly, but they are being fertilized by that ancient partnership between plants and soil microorganisms. So the plants are mining sunlight for that carbon fuel, and they're sharing it with the soil microorganisms, and they're trading carbon energy for nutrients and water and other stuff. So the carbon that builds up in the biomass of those soil microorganisms and in the biofilm, so they make what one scientist calls slimes, snots, and glues. They make a glue that holds together soil particles to make habitat in the soil beneath our feet. That carbon state that was in the atmosphere, it stays, it gets down there in the soil and it stays down there in the soil, and it's what makes soil fertile and friable. So if you compare the way nature grows things to the way people grow things, it's a big difference. There's nothing in nature that creates huge swaths of bare land. There's nothing in nature that turns up the soil the way our tillage does and breaks up that underground habitat of microorganisms. There's nothing in nature that poisons most of the living things on a landscape the way our pesticides and herbicides do. But there's nothing natural about having this huge landscape with only one plant growing, one kind of plant growing. So Gabe does not till or leave those big bare rows between his crop plants. He fills up those rows with other plants, which are called cover crops or companion crops, so that there's plenty of plant diversity in the field. And it protects the soil from eroding and all that. And it gives great habitat for insects. And he does not use chemicals on his land or his animals. And he tries to use machines as little as possible. So after he harvests a crop, instead of using a machine to get in there and cut down the biomass, he sends his cattle and his sheep and his chickens to pick through what's left. They eat bugs. They fertilize, they tramp down all that biomass into the soil where it can break down and protect the soil. So this kind of farming is called regenerative agriculture, and it addresses one of the biggest problems that we face around the world. So this land, instead of gassing off carbon dioxide, which is what most agricultural land does, it builds carbon in the soil. So most people don't realize that the legacy load of carbon in the atmosphere, that's the load that's already there, that a lot of it has come from the land. There's now 1 trillion tons of CO2 in the atmosphere, and 25% has come from and continues to come from destructive agricultural practices. So according to a report in 2018, agricultural land has lost 116 billion tons of carbon, mostly over the last 200 years. So that's a huge problem. There are nearly 2 billion hectares of land globally where crops are grown, and many of them use these destructive, destructive agricultural practices. But this is also really our great opportunity. I mean, a lot of land has been ruined and won't even grow for conventional farmers. We can take that land Regenerative agriculture is all about soil health and biodiversity and sturdy crops, and can give farmers a good living. And we can put some of that carbon back in the earth that way. So some outstanding regenerative farmers have succeeded in sequestering 10 tons of carbon per hectare on their land. So a few years ago, Gabe and I were in a movie together the movie's called Kiss the Ground, and it's about regenerative agriculture and this other response to our concerns about climate change. You know, mostly people just talk about ending fossil fuels and all that, which is fine and important, but we also need to heal the land so that it pulls down carbon and puts it back in the soil. So we were in this movie together called Kiss the Ground, and the filmmakers just came out with a sequel to that movie called The Common Ground. And that's Gabe there with a superhero cape on. And I think it's going to be a really great movie. I can't wait to see it. So probably most of us don't manage huge swaths of farmland or rangeland. We manage our own yards, or maybe a plot in a community garden, or maybe some pots on a porch. More than 80% of Americans live in cities, and a little over half the world lives now in cities. But that doesn't mean that we don't have an opportunity to cooperate with the rest of nature. We do, but it just means that we have to rethink our vision of cities. So I'm sure in addition to all the other things that we have to worry about, you've heard about, there's a biodiversity crisis around the world, that species of birds are dwindling, insects are dwindling, amphibians are dwindling. And a big part of the problem is that our farmland is either bare much of the year and doesn't provide anything in the way of habitat or food to all these creatures that have relied on it for all these years, or it's soaked in killing chemicals the rest of the year. And it really doesn't help wildlife enough if we set aside preserves where they can be safe from all this stuff, because they still have to cross over toxic landscapes to get to these preserves. So that's another benefit of regenerative agriculture. It provides habitat and food and refuge for all these living things. But activists around the world are also trying to get us to rethink our cities as places that can also be habitat, with things like green roofs. And so this is not a great picture, but this is a green roof. The first in the country, a green roof in Bend, Oregon, that used all native plants. And you can't tell, but it's 3 stories up, and there are all these great plants up there, and even up there, insects and birds buzzing around, taking advantage of the habitat and food, and green roofs, and anything green in a city really cools things and uses water well. So cities around the world greening with roofs and vegetation going up the sides of buildings, and having things like in Portland, we have this place, which is called Oak Bottom Wildlife Refuge. And it's a park in the city, but it's not a park where you have baseball games and birthday parties. There's little trails that go through it, and it's all about having wild nature in the middle of the city. We can go in there and see otters and beavers and minks. I don't know if they're native to the area, or there were minks that were set loose from a mink farm years and years ago. And I think these may be their descendants. So the human imprint is super small here, and it's large, but it's great opportunities for blue herons and swallowtails and all those other things. For this book, I got to go to I went to a conference in Paris called The Nature of Cities, with all these green activists from around the world who are working hard on greening cities. And it turns out that Singapore is the poster child for green cities. So 50 years ago, Singapore decided to reconceive of itself as a garden city, and now they're stretching that idea to a city in nature. They've known for a long time that cities that welcome the rest of nature, especially the plants, the insects, the birds, and the mammals native to the area, are going to be more pleasant for humans, as well as more resilient in an era of climate change. So they are enthusiastically greening every available surface in the city. Not every, but many. So this, I mean, this is so cool. This is public housing. Public housing with rooftop agriculture and gardens. They not only have 350 parks, but also 225 miles of park connectors, so people can walk from one to another. And they have 295 acres of green roofs, and also greenery going up the sides of the building, like that other picture I showed. But most amazing to me is, as the city population grows, the percentage of urban greenery has also grown. And they've been successful at increasing the numbers of some native species. So a woman named Lena Chan directs the city agency that's responsible for the greening. And I love her. It's these very green cities are called biophilic cities, cities that love life. I love her definition of a biophilic city. She says, a city is biophilic when the tree canopy and green cover increase every year, when more areas are restored with native species, when the number of native species actually grows, when the participation of citizen scientists grows, and when 50% of the population can name at least 10 native plants. Which that really speaks to me, because, you know, if you know the name of something, you can't help but sort of love it, have some affection for it. So Singapore proves that you can have thriving urban areas and biodiversity, but it doesn't have to be a zero-sum game in which human development and human thriving and prosperity means that the rest of nature is impoverished. And I think that's what ties together all these examples that I talk about in the book. You know, they are ways, people figuring out ways that humans can thrive, but also contribute to not just the survival, but the thriving of the rest of nature. So, any questions?
Singapore.
I want to go there. Yeah.
Well, I'm curious what other cities you found that are doing similar things to what Singapore is doing. I mean,
you know, so many cities are doing similar things. I mean, Paris was doing all kinds of cool stuff. You know, when I went to this conference, I had a broken leg. So one of the things I was really excited about going to that conference in Paris about was there were all these field trips to all these like amazing places where there were, you know, forests on the top of buildings, and where they had taken old railroad tracks and made these green belts and blah, 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 you know, all this great stuff that I couldn't go to with a broken leg. But they were, one of the, I just remember, I mean, they were doing green roofs and they were doing greenery on the sides of the building. They had a program that they were working on where residents could petition the city to come and remove parts of the sidewalk in front of their homes or in front of their buildings so that they could plant gardens or trees or whatever there. They were just looking at every opportunity they could to add green space. And it's just so, you know, in the book, I talked about some of the studies that have been done evaluating how humans are when there is or isn't green space around them. And, you know, we've all heard about those studies where if you're, you know, you're in a hospital and you even look at a picture of green space, you feel better. But, you know, scientists have gone into like public housing and compared two different buildings, some with where there was greenery and some where there isn't, you know, and there would just be like all these really, you know, fewer prescriptions for anti-anxiety medications and, less crime and all the, there's just all this. I mean, we evolved with, from the natural world. We need that interaction to be our best selves, psychologically and physiologically. So yeah, anywhere we can, more green. You asked me if I was thinking of a new book, and I am thinking a little bit, although I'm not sure, as I said, if I'm not just too lazy by now to work on another book. But I really want to focus in on, because when when you fly over a city, when I fly out of Portland, I'm just like horrified looking down there at all those, especially those industrial park buildings where there's these flat roofs that just go on forever. And I think that's not right. Every single one of them should have either a garden or a solar panel, one or the other. There should be stuff going. So I am really interested in taking a deeper dive into what cities are doing to add green space, develop those layers. I mean, why can't there be homeless housing up there? Why not? Yeah.
With regard to no-till, I always thought, yeah, that's the best thing ever. And then I discovered what no-till means for a lot of people, which is, and I saw this out of Montana, which you see these fields, they're just great. And what they do is they just nuke it with Roundup. Yeah. So that's what, and so the farmers really did not want to hear about how bad Roundup is. Right. Because they're no-till.
Right, yeah.
So they do.
Yeah, no, it's true.
They simply nuke their fields and they don't turn it over.
Right. And that is true for some of the no-till farmers. I think within the regenerative ag group, people are coming up with very creative ways to, I wish I had that picture. I had a picture of a no-till drill, which goes over the old biomass. I mean, they don't remove the old biomass except for with cattle. And there are these machines that go over that biomass. You don't even, it seems kind of incredible to me. I struggle with my garden, getting things to grow that I plant there, and seeds especially, but they have these no-till drills that punch through that old biomass and plant seeds, and it works.
Yeah, I was just sitting here looking that up, and there you have the discs that turn things over, but the no-till drills that I think they are more like knives that just cut parallel.
There are those, and that there are now ones that kind of do that. I just saw somebody with a picture of that, and then there are people who have who are coming up with all sorts of ways of dealing with that biomass. If they don't have animals to chew it up and stomp it down, then there's somebody came up with something called a roller crimper, which is a machine that they drag over there, and it just sort of smashes down all that biomass so that it can stay there, protect the soil, and just sort of die down until they're ready to plant again.
So my final question would be, what's the percentage of, having seen all these great fields out in Montana, mile after mile after mile, are you seeing a transition where these ranchers are starting to go in another direction? Or is it just like really small, just little patches?
It's really hard for people to change. I do see more and more interest and focus. When I first started writing about this stuff with The Soil Will Save Us, I thought there wasn't that much out there. I mean, there was Gabe Brown and a couple of other people who were doing really amazing work. And the USDA's Agricultural Resource Service, something like that, which is their biggest group that works directly with farmers. They were really working with farmers on trying to help them transition into healthy soil practices. And chemical sprays is not a healthy soil practice. And I do think there's more and more of it, but there also is, and I'm hoping, one of the most important things that happens every 5 years in this country is that the Farm Bill is reauthorized. There are so many groups that have come together, from the Sierra Club to, young farmers, all these different groups coming together to press for more conservation, soil health measures that will be in that. But so many farmers, they get a loan from the bank. The bank requires them to follow some of those procedures, to follow that chemical regimen. They get crop insurance. Crop insurance forces them to follow some of those chemical regimens. So all of that stuff really needs to change, and, hoping that some of that changes with this farmer. But then there are a lot of individual farmers who are making the changes. They don't want to be nuked in those chemicals either, and they are.
I would love to know how you got plugged into all this as a career path.
Well, I'm a writer, and I was interested. Although my grandparents were farmers, my parents were real backyard gardeners. And I mean, they had a vegetable garden that was just amazing. And they always had 3 bins of compost going. They were really into that. So I've always been sort of interested in growing things and how food gets to people, food gets to us. And so I was writing about some of that stuff, 15 years ago and all that. Then I had written about this chef I used to live in Cleveland, and I'd written about this chef who had started a pipeline of local organic food to his restaurant. And, that pipeline between local farms and restaurants had been broken years ago by farm consolidation. But he got it going again. And so I was writing about different things that he had told me about that was interesting. And at one point I said to him, well, what's going on in your world these days? What new thing is going on that I would find interesting to write about? And he said, well, carbon farming or regenerative farming. That's the thing that all these really interesting farmers are talking about. And he said it was farming where, farmers are trying to put more carbon in the soil than is released by the activities of farming. And I was like, oh my God, that just sounds amazing. We all worry about too much carbon in the wrong place. And I thought, wow, so, that whole line of thinking for farming, agriculture as a climate solution, that's really come far in the 8 years since I wrote that book, the other one. Anyway, I continue to find it fascinating and hopeful.
There's a question online. Are you familiar with Dr. Akira Miyawaki's mini forest work to reforest small places and 6 parking space size in large cities? His work is
I'm familiar with it. I'm not knowledgeable, but I'm familiar. Yeah, it's great work. Every time I see that's another thing that we could be doing on those roofs, doing that. But that's another thing, when I drive around and I see like a piece of, it's not even a piece of land that's not being used. And, especially since the pandemic, there are so many buildings that are like now boarded up and nothing's happening with them. I think, tear it down, put a forest there. Anything else? All right, well, thank you. Thank you all for coming.
Thank you.